This is for Year 12 methods. It comes out of 9C question number 12. So I have this curve, and this curve is a cubic, 3, and it's a negative cubic. So it's possibly, I don't know what it looks like. Maybe it looks something like, not quite sure what it looks like, but it's a negative cubic. Find the values of k. So I've got a parameter in here, k, with the tangents at the point 1 and the point -1/2. So the tangent here and the tangent here cut at right angles. That's what the question's asking. So the tangents at the point 1 and -1/2 are perpendicular. So if the gradient here happened to be A, then the gradient here would have to be -1 on A for these to be perpendicular. So y dash of 1 equals -1 on y dash of -1/2 should be what I'm looking for, and then that I could solve for k. So y equals 5/3 x plus k x squared minus 8/9 x cubed. And if I then take the derivative, I get 5/3 plus 2kx minus 8/3 x squared. And that y dash 1 will equal 5/3 plus 2k minus 8/3, which is 2k minus 3/3, which is 1. So that's y dash of 1. Y dash of -1/2 will be 5/3 times -1/2, 5/3, plus 2k times -1/2 minus 8/3 times -1/2 squared, which will be 5/3 minus k, that's +4, so minus 2/3, which is 5/3 minus 2/3, which is 1 minus k, is going to be y dash of -1/2. So if these are perpendicular, then 2k minus 1 equals -1 on 1 minus k. That's using this idea. Okie doke. So if I move this over, I'm going to have 2k minus 1. 1 minus k equals -1. 2k minus 2k squared minus 1 plus k equals -1. So if I move everything to the other side, I'm going to have 2k squared, this and this is 3k minus 3k equals 0, and the 1s and the 1s will cancel. So 0 equals k, 2k minus 3, therefore k equals 0 or 3 on 2 will be my answers. So what am I told about k in the question? K can be any value whatsoever. So we're looking for two answers for k, and those two answers are 0 and 3 on 2.